I'm Druid, spelled with an Uid. I'm going to be talking briefly about Metasploit Telephony. So basically, what is it and what's it for? So traditionally, Metasploit is a network attack framework. You have to put in, something in our host in order to target something. That's a little bit limited. I kind of work on the fringe type stuff, so I was like, hey, why don't we attack some dial-up stuff? So what this does is it provides a way to drive telephony devices. Right now it only supports analog modems. So yes, you do have to have a modem in order to use this currently. I've worked for the past couple years on VoIP stuff. I'll go into that in a little bit as to why that's currently not supported and what the issues are there. But the point is to dial up and provide a dial-up interface to remote systems. What this does is it slightly extends Metasploit's target pool from network systems to systems that are attached to telephone networks. The types of things that you're going to be targeting with this is vulnerabilities and things like bin login, your Gettys, PAM modules, modem drivers, stuff like that, and BBS software. Yes, BBSs still exist, and yes, there are a lot of them still out there if you care to go find them. So basically, all this does right now, this is still a work in progress, which is why it's Turbo Talk. It basically provides a modem object. And that object provides a few methods. You can create a new modem based on what serial port your modem's attached to. You can give it commands. You can read back the responses. You can hang up. You can flush the buffers. There's a few more, but those are the key ones that you're going to be using a lot. There's some accessors for configuration, so you can tell it which serial port you want to use, baud rate, data bits, stop bits, all your regular modem stuff. So how do you apply this? The dial-up exploitation module basically lets you create an exploit that uses the underlying modem object and the telephony stuff. So the methods it provides are connect dial-up, disconnect, puts, gets. You can do an expect based on regular expressions, things like that, and then your regular exploit handler. The configurations options that you see over there are basically all of the same ones that you pass to the modem. So that's how you configure your modem from your exploit. So there's a new payload which goes along with this called Unix TTY Interact. And basically all of this does is creates a interactive connection to whatever you've connected to with the modem. We don't usually get our shells in the usual way that Metasploit does. We're dialing up to something, potentially logging in, potentially exploiting something to get a shell. So we needed a new payload that basically just places the dial-up connection directly into the session handler. So then you can manage it just like your normal sessions that you get from your other exploits. Basically, it allows the user to interact with the TTY over the established socket connection. If you set your exploit to Unix platform and arcTTY for the architecture, then this payload will become available and you can use it in your exploit. The handler is called findTTY, and basically what that does is it finds the TTY for you and adds it to your session. So there's a test exploit that you can play around with if you just want to have it connect to something, make sure it works, make sure your hardware is configured properly. And it's in modules exploits test dial-up. Like I said, you set the architecture to arcTTY, the platform is Unix, and then it gives you the interact payload to use. And this is basically all it is connect dial-up, call the handler, and then disconnect dial-up. So it'll dial the modem, connect to whatever's there, and then put the session into your session manager. So here's how you use it. It's fairly straightforward. Use the use command, set your number that you want to dial up to, set your baud rate, serial port, any other configuration parameters for your modem, set your payload, and then type exploit. This is what the output looks like. You can see it'll go and initialize your modem. It'll dial for you. It has some timeouts that you can configure. I didn't really go through displaying all of those. It'll show your connect string, so a little bit of debugging output, and then it'll put in your session into the session manager and let you interact with it. So here's basically if you want to connect to something and your exploit has to do with logging in, going somewhere, doing something particular, it's not a traditional overflow buffer type exploit. You can use the expect and the puts methods to kind of script your login or your shell or whatever type of interaction you want to do. Here's an example. Basically connects, it expects a regular expression that matches the login prompt. You send what you've put in your username in the data store for the exploit, expect the password prompt, and so forth. And then call the handler once you've logged in. That'll give you your session and your session manager. You can connect to it and run commands, do whatever you want to do. Basically, if you dial up and you connect and then you authenticate, you write a local exploit out to a file, you can then run that local exploit. One of the things I realized after working on this for a while is we need to really abstract the expect stuff out to a general type of mechanism to interact with any session in your session manager. So that once you have a shell, if you got it through a normal exploit over the network, something like that, but it's, say, an unprivileged shell, running as the web UID or something like that, you might need to run a local exploit to elevate privileges. Hopefully I can get that abstracted out to a more generalized type of mechanism, and then you can use it to execute local exploits over your regular sessions. So here's an example of a real exploit that uses this, and it's one of the few that I found that was actually applicable to this. Like I said, I tend to work on stuff that's kind of a cool idea but not real useful. So this one is there's a overflow in bin login that's derived from System 5 bin login. Solaris uses this, a few other Unixes use this. But this is a really old bug. As you can see, it's CVE from 2001. But it demonstrates exactly what this is for. So the way this bug works is you provide a large number of environment variables to bin login via the username login prompt. So you put login, username, and then you can define environment variables after that, which bin login will set up as a predefined variable name with an incrementing value on the end. I don't remember exactly what it is. There's another way to get to this over a telnet vector, but this one works best for dial-up. So the point is exploitation can be done entirely through the unauthenticated user prompt. And what it does is it provides a shell basically bypassing the password. You still enter a password, but it doesn't check anything. It just drops you to the shell as the user that you're attempting to log in as. Here's how you use it. Basically the same as the test exploit. I'm not going to go into that too much. And this is what it looks like when it works. When I was testing this, I was basically dialing out over a VoIP connection to an Asterisk server up to one of HD's VoIP providers for Warvox, and then back down through Time Warner's VoIP backend into my cable modem, and then to my Spark station sitting next to me in the same room. So it was a little unreliable. I'm not sure if that's due to the exploit or due to the convoluted way that I was dialing because I don't have copper in my house. But it does work, and it demonstrates what this is for. And this is also in the development framework trunk if you want to check that out through SVN. So how do you find these types of systems? I mean, yeah, it's interesting that you can dial up and attack, stuff, but dial-ups are still becoming increasingly rare. They are still out there. So what I did was implemented a war dialer using this underlying telephony code. And while I was, bugging HD with questions about, different Metasploit development stuff, this is what kind of put the Warvox idea in his head, and he ran with that. So there's some differences in the two, and I'll talk about that in a few minutes. Now basically what the Metasploit war dialer is it's your standard war dialer, has most of the options you'd expect. You can detect, it'll log most of the modem response codes from the modem because the modem is actually doing the connection and doing the verification of what it's finding. And it stores all of its information under your MSF working directory under logs war dial. There's a gzip marshaled Ruby scan database object. So if you want to do some kind of third-party app that uses that information, it's there. You just have to ungzip it and then use it as a Ruby object. And it also has a tone-log style found.log, which records all of your connections and interesting hits, whereas the database has all of the numbers you're scanning. And it can also log to a SQL database. So basically the options are all of the same ones you had for your modem object, but there's an additional set, which are like your dial mask prefix, things like that that you're going to need to drive your modem scan. Oh, wait, let me go back for a second. There's also a log method, which is how you tell it whether you want to log to a file or to a database, things like that. There's a configurable nudge string so that once you've connected, if you're not getting anything back, it'll occasionally send the nudge string to kind of prompt a response so that you can log some of the banner information and that kind of thing. So the way you use it is it's set up as an auxiliary module. So you use auxiliary scanner telephony war dial, set your dial mask. You can use either X's or number signs there. It'll translate whichever digits that you want to mask out into the numbers that it randomizes. You give it a prefix if you need to do other things, and then you just run it. Hopefully you can see that. Okay, good. Basically, it runs like this. If you start it up, you've never scanned this prefix before, it'll create your database or your Ruby database, and then it'll detect the masked bits or masked digits in your dial string and generate that many records in the database for it to use. So as soon as you dial, it's got all of the numbers in this database, whether you've identified them or not. Then it initializes the modem. It starts running. In this case, I had the modem set to fax mode, so I was scanning for faxes, and you can see like the second number it dialed, it actually found a fax. And then it just continues on until it either dials completely or you stop it, and then because all of the output is in this database, you can resume where it left off later. So database logging. It can store the results through the Metasploit database abstraction layer. Basically, all it does is it calls a report note with a type of WARDAL result and puts the information in there. It does this for all of the interesting things that it's found, basically the same information that goes into the found.log in the logging data, directory. Eventually, this is going to be able to interface with another project that I've started called Tidbits, which is the Internet Database for Information Telephony Systems. And I'm intending for that to be just a massive database of any system that's attached to a telephony device of any kind. The point of doing this is you can then have multiple Metasploit war dialers feeding this database, and eventually it'll actually be able to pull targets back out of the database that need to be verified, that may have been submitted anonymously, things like that, essentially turning it into a distributed war dialer. So what's missing? Like I said, this is still a project that's kind of new and ongoing. One of the things I want to do is have direct VoIP support. Right now, like I said, it's hardware modem only. You have to connect it to your serial port, drive it that way. The reason that it doesn't support VoIP right now is there's not a really good VoIP DSP. There's one that supports connecting to faxes, so I could use that and you could scan for faxes, but you wouldn't be able to connect to a data connection using that. There are DSPs that do this, but they're either hardware or in a modem or not really designed to be interfaced with VoIP, so there's some work to be done there. Like I said, IX modem exists. It uses this particular DSP on the back end, which is the one that only supports fax. And this is actually one of the reasons why Warvox went the approach of doing signal analysis on the audio that it records. It actually uses this code to do the dialing, but it can't make a data connection. So it records the audio and it does signal analysis on the audio to do all the really cool stuff that it does. I'm not going to talk too much more about that because HD is speaking on it at Security B-Sides, I believe, Saturday. So if you're interested in Warvox and more war dialing stuff, you definitely should check that out. More exploits. Right now, the only one that's in the framework is the one that I covered. There's a few other potential ones that might be able to work this way. I haven't looked into them yet. And a friend of mine tipped me off to an O'Day and Renegade BBS software, which I need to check and see if it still works in the current version. So you might see that popping up in Metasploit sometime soon. Also doing non-carrier signal processing. This is kind of what Warvox does that I mentioned with the audio analysis. Because my eventual goal is to have this feeding into the tidbits database, we also need to scan for things like voicemails and basically any kind of information telephony system, not just carriers and faxes and things like that. Hopefully we can get some of the Warvox code back into Metasploit because it is implemented as a completely separate project and separate code base. But I think there's a lot of potential for shared code use there. So that's about it. I told you it was going to be relatively quick. So I've got some time for some questions, I believe. And if anybody has any, I'll take those now. Nobody. All right. Yes. Basically just time and effort. If I remember correctly, I did look into a little bit with the GNU radio project. It seems that most of the code needed to do it is there, but that's geared towards RF, and they're hardware and working that way. So I believe the code all exists. It just needs to be put into an interface with VoIP protocols. The easiest way to do that would obviously be to get the DSP maintainers to add that type of functionality, but they have the perspective that, if you want to connect to a data system, you're already on the internet or the network because you're using VoIP. Why don't you just connect to the data system? They don't see the need to actually have that functionality, so it's very hard to convince them to do that. And so far it's been completely unsuccessful on my part. Anybody else? All right. Nope. Yes. The nudge string is basically so that when you dial up to a system, sometimes it'll connect, but then it'll just sit there. Occasionally you need to prompt the other system to feed data back. So you send certain characters, carriage returns, things like that, some control characters, to try to prompt the system into responding with its banner and its login prompt. Because sometimes you'll connect and nothing will happen. So that's what the nudge string is used for. Anybody else? All right, thank you very much. I appreciate it.